So on to a couple definitions. The linear inequality in one variable, what the author is trying to get at here is that we can take mx plus b and we can make it less than 0, make it greater than 0. Now these aren't going to graph like lines. That's not quite what this is talking about here. It's saying, look, you have one variable, x. So if you have one variable and it's only to the first power, then that's a linear inequality, right, with the less than or greater than sign. You could, of course, have x squared or x cubed. I mean, you can do other things with inequalities. But in this particular course, all we're going to work with is linear ones, where x is only to the first power, to which you are grateful because when it's squared or cubed, that, of course, makes things more difficult. Now, we say that a number is a solution of an inequality in one variable if it satisfies the inequality. In other words, if you substitute in that number, it keeps it unbalanced. So for example, I don't know, if 0 was an answer to this problem down here, that means if I put 0 in for x, then this side, left side, is still less than that right-hand side. Okay? Solution set is all the solutions that are possible, and we solve an inequality by finding its solution set, which is what we were doing up here, right? We found the solution set, which is all these numbers that are greater than -4. We graphed them to show what they look like. We can write them in an inequality, or we could write them in an interval, right? But they're still the solution set. It's all the possible values. Okay, so we are going to do it with these problems. Now, as you can tell, these are going to be more tricky. And one of the first things that spot that it's more tricky is that it's got fractions in it, which, we know that you guys all know and love, right? Right. Okay. Now, the good news with this particular problem is that, like an equation, it's got this inequality business in it, and that means, in other words, it's a statement. It's got less than or greater than or less than or equal to, greater than or equal to, which means that you'll be able to get rid of the fractions in one step. You don't believe me, do you? Oh, but I wouldn't lie to you. You're going to multiply everything by the LCD, the least common denominator. So you want to look at all your denominators, 8, 4, and 2. And you want to find what all three of them go into. That's what makes it common. It has to be common to all three of them. It has to be a denominator, and it has to be the least one. It honestly doesn't have to be the least one, but it's easiest on you if you pick the least one. So you think, okay, 8, 4, and 2. 8, 4, and 2. What do all three of those numbers go into, divide into, is what I'm asking. So some students might say 4. Well, 2 goes into 4, great. 4 goes into 4, great. But 8 does not go into 4. 8 doesn't divide into 4. But 8 would work. And I'm going to do 8 over 1 because this is a fraction. So I'm going to say, okay, I'm going to multiply everything by 8. Everything. Oh, that's right, all of it, the whole thing. So I'm going to multiply that first number by 8. That's 13 over 8 times 8. Then the second number times 8, 7 over 4 times 8. And then this third number times 8. All of it gets multiplied by 8. And I know what you're thinking. You're thinking, Alana, that makes things worse. No, it didn't, I promise. Because you've got this first number right there. That's that one. You've got this second number right there. There that is. Then you've got the third business right here. And then you've got the less than. Now, I promise you, it made things easier on you. Here's why. 8 and 8. Don't 8 and 8 divide into each other? Right? 8 over 8 makes 1. So this is 13 times 1, which last time I looked was 13 minus. All right. What about 4 and 8? 4 goes into 8 how many times? See, that's why you picked a number that was common, right? That all of these divide into. See why you were doing it? Okay. So it's 2, right? 4 divides into 8, leaves you 2. And 2 times 7, because you're multiplying still, this is still a multiplication problem, is 14. And then you still have that x sitting right there, which you haven't done anything with. So you have to write x. Less than or equal to. All right, now 2 goes into 8. If you hear any barking, my dog is having puppy dreams at my feet. It's kind of cute. Okay, so 2 goes into 8 4 times. So then you've got 5 times 4, which makes 20. And there you go. In one step, this ugly step, I know it's ugly, but in that one step, you have made it so that you have no more fractions. If it doesn't work, that means you didn't pick a common denominator. right? It has to be a number that would make all the fractions disappear. You need a number that 8, 4, and 2 all divide into. That way you have no more fractions. And at this point, this isn't a hard problem to solve. You subtract 13 from both sides. Okay. So you're going to have negative 14x. Oopsie, sorry about that. A 14x is less than or equal to 7. Then you want to divide by negative 14 to both sides. Okay. Now what's that going to leave you with? On the left, negative 14 over negative 14 divides away, right? And it leaves you 1. So in this case, it's 1x, right? Because we had the x still sitting there. So it's x is less than or equal to, and everybody knows, hopefully, what this is. 7 and 14. 7 goes into 14. Oh, wait. There's a typo. No, it's not a typo. I did something wrong. Did you catch it? I didn't catch it. Got so busy typing. Okay, so we subtracted 13. That's cool. We got here. That's fine. Everything's good so far. Except, what happens when you divide by a negative like this? I shouldn't have typed it that way. I should type it this way. See? When you divide by a negative, better make a note. Note. Divide by negative. Switch or flip sign. Okay? Whenever you divide by a negative, you must flip your sign. I'll make a little note to ourselves. Alrighty, we've got that part. Now it said to write it in inequality notation. That's what I just did down here. That's an inequality notation. You can tell it is because it uses an inequality symbol. See, like a greater than or a less than, that kind of thing. Fabulous. Now, we also need to graph it and do interval notation. And I would suggest doing it in that order. I think that the interval notation is easy to figure out once you have the graphs. So let me go draw a picture of that. Hold on. There we go. There's a picture. So you can see it has a closed dot at negative 0.5 because we actually get to be negative 0.5. That's what that extra little bar down there means. It means you get to be negative 0.5. And it's greater than because we had to flip the sign. Right? NEG, flip the sign, exclamation points. Make notes to ourselves. Okay? So we had to flip the sign so it turned into a greater than. So we shade to the right. Close dot at negative 0.5 because you get to equal it and go to the right. And I can't put the arrow, but you should actually make a little shaded arrow over here. But I can't do it on the computer. All right, so then interval notation. Well, let's look. We want it to be closed dot. Closed dot always means bracket. So I'm actually going to get to do a bracket this time, but on the left-hand side. And then the right-hand side, it's going to be a parentheses. So it's negative 1/2 or 0.5 if you want a decimal. I don't really care. And then it goes forever and ever and ever and ever. It does not stop here at 10. It just looks like it does with my computer program, but it keeps going. So you have to keep going and give it infinity, right? Because it never stops. 3 million is bigger than negative 1/2, right? So there's interval notation. Done. Let's hope that the other one's easier. Okay, so let's see here. We've got 3x plus 6 greater than 5 parentheses 2x minus 3. Okay, now we want to solve this for x. So first thing we want to do, that's not necessarily the first thing, but it's the first thing I'm going to do, is I'm going to distribute my 5. So it's 10x minus 15. Don't forget to do it to both of them, right? Not just one. Now let's see what. We want to get the x's to one side and the other stuff to the other side. It kind of doesn't matter which way you go. So, I don't know, for the fun of it, how about I subtract 10x from both sides? I'm just going to do this in 2 steps. I wouldn't normally, but I don't want to get you guys confused. So it's going to be negative 7x plus 6. Oh, goodness. Negative 7x plus 6 is greater than negative 15. Oops, 15. Now, there's no problem with the sign at this point, so don't get all bent out of shape and say, oh, Lana, you got to switch the sign. No, 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 no. You only switch the sign when you divide or multiply by a negative. We have not divided or multiplied by anything at this point. All we did was subtract. Subtraction's a-okay. So we subtracted, we got negative 7x plus 6 is greater than negative 15. All right, now we'll subtract 6 from both sides. And again, we're not going to bother with the whole switching sign thing because we're just subtracting. We're not actually, oopsie, doing division. Division is the one you got to watch out for, and multiplication. So that leaves you negative 7x is greater than negative 21. All right, now we're going to get into trouble because we need to divide by negative 7. But when you divide by a negative, you must switch the sign. Let me make a note. Note. Because divide by negative. Right, we divided by a negative thing, therefore we had to switch the sign. So it's going to be x. We haven't switched it yet, right? So it's still, mouth is on the left-hand side, mouth is on the left-hand side. So I'm now going to switch it and make it pointy ends on the left-hand side, except I'm going to do this in math notation. X less than, and negative 21 over negative 7 is 3. All right, there's my inequality answer right there. Make a note. All right, done with that part. Now I need a picture of it. So I'm going to need a number line. I need a dot on 3, but I can't be a closed dot because I don't get to actually equal 3. So I'm going to need an open dot on 3, and I'm going to have to shade to the left because I want things that are smaller than 3. So let me go do that. And there we go. Open dot on 3, shade to the left. You want an arrow kind of end over here. I can't do it because of the program I'm working in, but you want to kind of make it have a little arrow. Oh, maybe I can try. Is there an arrow shape in here anywhere? There. I don't think that's going to work. I thought I was talking to you, and I guess I wasn't, so bear with me here if I repeat myself. But there's the 3 right there, open dot, because we have no or equal to sign. And I shade to the left, and I was able to put some arrows in there, right there. Arrow in there. Cool. And then for interval notation, you don't get to use a bracket because you never have a closed dot on this problem. You don't have a closed dot over here to the left because you keep going and going and going like the Energizer Bunny. And you don't have a closed dot over here on the right because you only get to 3, but you have an open dot because of the, it's just a less than. It's not a less than or equal to. So they both are parentheses. You don't get to use the bracket with the hard edges on it. Right? Those only get used for closed dots, which you don't have one. All right, hopefully I didn't repeat myself too much, or skip too much for that matter. Okay, let's look here at the next page. Oh, okay, a 3-part inequality. So what this is saying is, look, x is bigger than 2, but smaller than 5 at the same time. Let me show you what that would look like in a graph. Poof. So you have a closed dot at 2, all the way up to 5, closed dot for both of these because they both have that less than or equal to symbol. Which would mean in interval notation, it'd be 2, 5. 2, 5, because they both have closed dots. Like that. I wanted to add this in real quick. What if it had been 2 is less than or equal to x, which is less than 5? That would mean an open dot on 5, which would mean that would be your interval notation instead. Because you never actually get to 5 with a closed dot, so you can't get a bracket on the 5. But you can have a bracket on the 2.